Hi there, I'm Tony Northrup for Train Signal, and in this video lesson we're going to learn how to configure file and folder access in Windows 8. This lesson maps to the Microsoft Certification Exam 70-687, objective number 4.2. This objective has 4 sub-objectives: encrypt files and folders by using EFS. That is file encryption that will keep your files secure even if somebody physically steals your PC. You'll also learn how to configure NTFS permissions. NTFS is New Technology File System, and it's not new technology, but back in the late 90s, 96, 97, Microsoft released an operating system called Windows NT, and it's the architecture that would later become Windows 2000, and all the current versions of Windows are based on this original NT core. And one of the innovations with Windows NT was this new technology file system, the NT file system. We still use it today. It's been around for like 15 years now with basically no changes whatsoever, really minor tweaks. Anyway, one of the features of NTFS is the ability to assign file permissions that define who can read and write your files as well as who can't touch them at all. So we're going to learn how to do that. We'll also learn how to configure disk quotas. A disk quota just specifies exactly how much space a user can use on a disk, and if they go over that, it either throws an alarm or just stops them from saving any new files. And finally, we'll learn to configure object access auditing, and that's a really confusing way to say we'll learn how to watch what people are doing on their PCs. We'll be able to trigger an alarm if, for example, somebody opens a file they shouldn't be looking at. For our first demo, we're going to configure those NTFS permissions that I told you about. So here we are in Windows 8, and to edit NTFS permissions, you need to use File Explorer. So I'll jump to the desktop. Here in File Explorer, we can browse the files on the local computer. So first let's check out the file permissions assigned to the Windows folder here. I'll right-click it and then click Properties. Now, file permissions are always accessed from the Security tab of the File or Folder Properties dialog box. Now, here we see a listing of all the different users and groups that have access to the Windows folder. Actually, that's not quite true. Here we see a list of all the users and groups that have an access control entry. And I'll tell you why that's different from just having access. You can have an access control entry in here, but have permission denied to you, in which case you definitely don't have access, but you would appear on this list. But the default permissions don't deny anyone access, they simply grant access. So let's take a look at the default permissions for the Windows folder. You can see they grant access to the users group, which all users are a member of. Now look at the permissions that they grant. You have read and execute, which lets you open files and run apps. You can list the folder contents, which just lets you browse the folder. And you can read files. Read is a little bit different than read and execute. If you had read and didn't have read and execute, you'd be able to open a text file, but you wouldn't be able to run an app. You'll also notice a special group here called All Application Packages. Now, these application packages are the way that Windows 8 apps get installed. This is a new group. And of course, apps need to be able to read system files. They don't need to be able to update them, so they don't have modify access, but they need to be able to use system libraries for things like drawing a window or a button on the screen. That's why they're granted read access. So those system permissions are really straightforward. Let's take a look at user permissions. I'll open up my own profile folder here and check out the permissions for my Documents folder. Just right-clicking it and then clicking Properties. Now I'll select the Security tab. Here we see something interesting. The System account, which represents Windows 8 itself, services that do system stuff like search files and index files. It has full control, modify, read and execute. It has everything. The system can do anything, which makes sense. You want your system to be able to do stuff. full control here. As with shared folders, it allows the individual to change these permissions. If you had modify file access, you'd be able to update files, but you wouldn't be able to grant somebody else permission to update the files. If you have full control, you can actually change the permissions too. The difference between modify and write allows you to create new files, while modify allows you to change existing files. Usually those two are assigned together, but you can separate them. Now, taking a look at my own account, you can see that for my own files, I have the same permissions as system. Of course, they're my files, so I can do whatever I want with them, and it's not going to try to stop me. And if you check out administrators, anybody who's an administrator on the computer could also go and access my files. They have full permissions, so they could even grant access to other people. However, you'll notice that there's no everyone here. There's no other users listed here. There are other accounts on this computer. However, none of them have any access to my files. I'm listed, administrators are listed, and system is listed. So Mary, who has an account on this computer, can't touch my files. And likewise, I can't touch her files. So just to demonstrate that, I will click Mary's folder there, and you can see it prevents me from accessing her folder. Now, it prompts me, and it tells me you don't have access to the folder, but you can get access to it by clicking continue. And you see from that little shield there that means that it needs administrative access. So I happen to have administrator access, so I could click continue and get access to her folder. If I didn't have administrative access, that would be the end of it. I wouldn't be able to get any deeper. So let's take a look at the security for her folder. Now, you'll notice something interesting. Her account's listed just like mine was listed. My account is now also listed. That's because when I clicked that button to permanently gain access to her files, it just automatically gave me permission. I was a member of the administrators group, which allowed me to access her files. Let's change hats and switch over to Mary's account and see what it's like for a standard user to try to access another user's files. So now you can see I'm logged in as Mary, and I'll jump back to the desktop here and open File Explorer. So of course, Mary can access her own files, no problem at all. When she tries to get into my files, you don't have access. So again, it prompts her to provide administrative credentials. She doesn't have them, so she'd have to type a password. And if she doesn't know, she'd have to click no. So Mary can't get to my files, any of them. This is one way that Windows 8 protects users from each other on the local computer. Now, these file permissions that we talked about, they apply to other local users. They also apply to users over the network. So if you want to share your documents with somebody else on the network, you share them, just like we covered in another lesson. Sharing requires administrative credentials. And you can configure the share permissions here. However, beyond just sharing, you also need to assign NTFS permissions. So I've shared her documents folder, and now I'm going to go into the security and remove Tony's access here. So I clicked the edit button here to open up the permissions dialog box. Now I'm going to select the access control entry for Tony. Remember, I'm logged in as Mary now. Now you can see as I tried to remove permissions from Tony, I got an error message, and this error message hints at something really important, and that's NTFS inheritance. By default, there's a lot of folders on your hard drive, thousands of them, especially once you dig into the system folder. There's a lot of different subfolders there, and you don't want to have to assign permissions to every single folder manually. So NTFS permissions have the concept of inheritance. That just means a subfolder gets the exact same permissions as its parent folder by default. So I was trying to remove a permission from the My Documents folder. However, when I accessed Mary's folder, I claimed it for the Mary folder here. My Documents inherits the permissions from Mary. So I can't change the permissions for My Documents, at least I can't remove an existing access control entry. I need to work with the parent folder. So I will close this out and then edit Mary's profile folder, which is the top level folder that has this permission assigned. So once again, I'm editing the permissions and I'm going to select Tony Northup here and I will remove it. Now, the Tony Northup account is a member of the administrator's account, which still has access. So Tony Northup will still be able to go in and claim access, just as I demonstrated earlier. You can see that it's demonstrating some errors as it applies the new settings to all of the child folders. These aren't something that's particularly important for the example that we're doing. These are special locations that standard users don't have permission to edit the properties for, which is why this error is coming up. If you were an administrator, you wouldn't have this problem. So now let's take a look at Mary's My Documents folder, and we'll see that the child folder is now missing the access control entry for Tony Northup. So as you recall, we shared this folder. It's shared as Win82 documents, and we granted Tony Northup share permission, but now Tony Northup doesn't have file permission. And just to be sure of that, let's say I really hate Tony. I'm going to add an entry for Tony Northup and deny him access. So I click the edit button here to open up the permissions dialog box, and I'll click add. Now I'll add an access control entry for Tony Northup, and I'm going to deny him access. You can see that this dialog box explains how deny works. Deny overrides other permissions. So Tony's a member of the administrators group, and the administrators group gets access to the file. Thereby, Tony has access to the file. However, if I deny access to a user, the deny always overrides any permissions granted through group memberships. So once again, it's giving me warnings about applying the security. However, we can see that it did take effect here. So Tony will be able to access the share, but not the folder itself. So let's log in as Tony. And I will jump down to the desktop, and in Explorer, I will attempt to map that drive. I'm using the Easy Access button here on the toolbar. Now, when we map a drive, we need to type a UNC path. It's always // and then the server name. If you're not sure of the server name, you can always do localhost. Localhost always refers to your current computer. It's just a shortcut. So this will map the Z drive to Mary's shared folder. So something interesting happened. It connected to the share. It didn't give me an error right away, but then it gave me this error. I do not have permission to access localhost documents. It's kind of complex. Now, scrolling down here and selecting computer, you can see I did map a drive successfully to that shared folder, and that means I had share permissions. However, I don't have NTFS permissions. You see, Windows has two levels of security for shared folders. There's the share permissions, and the lower level file permissions, the NTFS permissions. You have to have access through both those levels of security. If you have share permissions and you don't have file permissions, this is what happens. You can map the drive, but then if you try to open it, you get an error. If you have file permissions but not share permissions, well, you can't connect to the share in the first place. However, you could log on to the local computer and access the files directly, not through a share, because you have file permissions. Now, I'll just give you a tip about applying file permissions. In the examples that I've been doing, I've been assigning permissions to individual users. In the real world, the way you're going to do it is you're going to assign permissions to groups. So you'll create groups for, say, the accounting department, or a group of managers, or temporary workers. And then when you want that group to have permissions, you'll assign permissions to the group. even if there's just one person in the group. If you have one accountant, guess what? You should create a group called the accounting group. And instead of assigning permissions to that one accountant's user account, assign everything to the accounting group. And here's why. Because that accountant could leave one day and be replaced by somebody else. And you don't want that person to have to log in with that person's account. No, it wouldn't be secure to do that anyway. Instead, what you'll do is you'll just create an account for the new employee, put them into the accounting group, and then remove the old employee's account from the accounting group. So whenever you're assigning permissions, whether they're share permissions or file permissions, remember, assign permissions to groups and then put users in groups. Don't assign permissions to users. I do it for the sake of keeping the example simple. So one built-in group is power users. There. So now I'm assigning permissions to that group instead of the user. That's the smart way to do it. The same error message again. So here's a scenario where we'll get to have some fun. We're going to create a couple of folders and we're going to protect them with NTFS permissions and EFS. EFS is the encrypting file system. It uses cryptography to make your file into nonsense that only you or people you share your key with can read. We need to share some files with Mary, and we're going to use a couple of different levels of security. Then we're going to make sure that Mary can read those files, and then we're going to try to hack them. So we're going to bypass Windows completely. We're going to boot from a Linux live CD and see what we can do. So here's my computer. I will jump over to the desktop. And in my documents here, you can see I already have a secret stuff folder. That's what I want to share with Mary. I have created a protected file. So let's check the file permissions of secret stuff here. Okay. Only I have access to it. I'm going to need to grant Mary access to it. So I'm clicking Edit to open up the permissions for secret stuff dialog box, and then I'll click Add. And I'm going to specify Mary's user account. There it is. And she has permission to read the files in this folder, and that's good enough. I'll also share this folder so that Mary can get to it. Set the permissions so that Mary has access and nobody else. So share permissions set, file permissions set, and we have one file here. I'll check the security on it, and you can see that it inherited the permissions from the parent folder. So because I changed the permissions on the parent folder, this file and any new files in it, as well as existing files, will get the same permissions. Makes it easy, right? Now that's a protected file. Let's also use encryption and add an additional level of security. So I will save that file and close Notepad. Now let's set the security on it. Viewing the properties of it, and from the security tab you can see same NTFS permissions inherited from the parent folder. On the general tab here, I don't know why they make it so hard to encrypt something. You'd think it'd be on the security tab, right? No. To encrypt something, you go to the general tab and then you click the advanced button. I don't know why. And then down here under compress or encrypt attributes, there's an encrypt checkbox here. So now once I click apply, you can see that the file will be encrypted. It's prompting me to also encrypt the parent folder, but I just want to encrypt only the file. So I'm going to select encrypt only the file. And the first time you encrypt something, it creates an encryption certificate for you. And this does a few things. It's prompting me to back up my certificate. And that's really important because this certificate allows you access to the file. Without the certificate, you don't get access to the file. It's exactly like you're a hacker. And as we'll see at the end of this scenario, hacking an encrypted file is not that easy. So you always want to take the time to back up your certificate. We'll learn more about managing certificates in a different lesson. So now that the file is encrypted, I can click the Advanced button again and go in here and click the Details button. Again, I don't know why this user interface is so terrible. There should be a tab for encryption, but the Details button allows you to share the file with other users on the same computer. So you can see by default, there's just my user account and my certificate here. So only I would be able to access this file. I want Mary to be able to read it. So I'll click Add here, and now I can choose Mary's certificate. Now, here's an important trick. The user has to have had used EFS at some point, or they won't have a certificate. You saw that my certificate got created automatically the first time I used EFS. So if you go to share it with another user and their account doesn't appear here, that means they don't have a certificate. Just tell them to go and encrypt any file on their computer. It can be a temporary file. They can delete it immediately afterwards. That creates their certificate. From that point forward, you'll be able to specify their certificate for sharing. So now I've granted access to Mary to access my encrypted file. I'll also point out that down here you'll see recovery certificates. This in an Active Directory environment allows administrators to recover anybody's encrypted file. It just makes it easier to manage. But for the sake of this scenario, we're just sharing a file with Mary. All right, so the scenario is moving forward. To recap, I need to share some files with Mary, and I'm doing it using a couple of different security techniques. I've created a shared folder called Secret Stuff. And in that folder, I've provided access to two different files. One file called Protected File, which is protected with the NTFS permissions of the parent folder. Another file called Encrypted File, which is also protected with the NTFS permissions, but in addition to those file permissions, it has encryption, which provides a different type of security. So let's become Mary now, and we will try to access that file. Logging on as Mary, and I'll jump to the desktop. So I'll go ahead and map a drive. Great, now I can see the file that Tony shared. I'll see if I can open up Protected File. Indeed, it does allow me to open it up, see if we can change it. Yes, it prompts me to save it as a different file because it doesn't have access to overwrite it. So as we can see here, access is denied. So indeed, I have access to read it, but I can't update it. Now we'll open up the encrypted file, and sure enough, Mary can access the encrypted file too, because I added her certificate. Now, if I hadn't added her certificate, but she had NTFS permissions, well, she wouldn't be able to open it because it's encrypted. She'd be able to read the file, but she wouldn't be able to decrypt it. So it would just look like random garbage. Now, we've been Tony, we've been Mary. We're going to be an anonymous black hat hacker who wants access to these two super important files. This hacker has stolen my laptop computer from the airport. So they have physical access to my computer, but they don't know my password and they don't know Mary's password. So they try to bypass Windows security by booting from a Linux live CD. So I'll put that CD in now and boot it up. So this is not something you need to know for the exam, so I'll move quickly through it, but I'm booting Hiron's boot CD, and it's not a hacking tool. It's really just a disk repair tool. It has lots of useful tools on it, including tools that will let you read files directly from the disk. So there's lots of different tools you can choose from here, but I'm going to boot up the Linux-based rescue environment and select the default options, which just uses the US English language. So Linux is this open source operating system, which means the software is freely available, all the source code, you can do whatever you want with it, and it's super powerful. Lots of stuff you use all the time are based on Linux, including Android phones and the Chrome operating system, Linux is exceptionally powerful. And you can also run Linux on desktop PCs, and the number of tools available for Linux is incredible, especially considering that it's free. Now, we have a Linux environment loaded up. I inserted a CD into the computer and booted from the CD, but it could also be stored on a flash drive. So anybody who can boot a computer from a CD or flash drive can do this. Now, the new Secure Boot technology in Windows 8 can thwart this, but most existing computers don't have Secure Boot. So with this environment running, I will open up File Manager. And it's representing the C drive as this particular 121 gigabyte volume. So here we can see all the same files that I can access from within Windows. And I'm drilling into the users folder and then the Tony folder, into my documents. Here's the secret stuff. Why is NTFS permission not stopping me from doing this? You can see I didn't enter a username or password. I'm the Black Hat hacker at this point. I don't know the password, but I was able to get right past all those NTFS permissions and edit the protected file. NTFS permissions are meaningless when Windows isn't running. Windows is responsible for enforcing the NTFS permissions. So without them, anybody can access anything. They can make changes. They can read your files, they can copy them, they can put them on the internet, whatever. You can see I edited this file that I shouldn't even have access to read. It's pretty remarkable. Let's try this with the encrypted file. We get an error. Failed to read. Permission denied. It's not really permission denied. The file is encrypted, so this particular tool doesn't know how to read an encrypted file. And in fact, it would never be able to read it unless it had that certificate, my EFS encryption certificate. And to get the EFS encryption certificate, you know what you have to do? You have to log in with my username and password. And the hacker doesn't know my password. So as long as I keep my password secret, he's not going to get my certificate. Now, you have some options here. Since we're wearing our black hat and we're a hacker, we can try to crack the certificate. And that means running a tool that just tries every possible combination of different certificates until it finds the right one. And that would take, with a really powerful modern PC, that would take hundreds of thousands of years, millions of years. You're not going to live to be that old. You're not going to have time to, the contents of that file are valuable, mind you, but you're not going to be able to do it. Now, my file is not that important, but for military purposes, for government purposes, this sort of encryption is really important. And the people who would crack it wouldn't be using a modern, powerful computer. They'd be using thousands of powerful computers with state-of-the-art technology. So the encryption is designed to prevent those from cracking anything in multiple lifetimes, thousands of years. Strong encryption, and there's no easy way around it. In fact, since I have my black hat on, my technique would be to try to crack Tony's password, to log in as him. That way I could just get his certificate. It's much easier to crack a password than it is a certificate. Good reason to keep your passwords long and complex and not in any password dictionaries. So let's move on to the next subobjective. In this subobjective, we're going to learn about disk quotas. Disk quotas just stop users from consuming up so much of the disk that they fill it up. You can control exactly how much storage space each user on a computer gets. It's mostly used in an enterprise environment. It can be particularly useful when people share a single computer. Let's get started. Here's my Windows 8 PC. Like most things, I need to access the desktop. I will open up File Explorer, and now I'm going to right-click the drive and click Properties. You can only do this from the drive itself, not from individual folders. So with the drive properties showing here, I'll select the Quota tab, and then I will show the quota settings. This requires administrative privileges. Now, obviously, I need to select the Enable Quota Management checkbox, and this allows me to change the other settings here. So the most important setting here is going to be the limit disk space setting. You can see that by default, disk quotas set a pretty stingy limit of 1 kilobyte. I don't know anybody who can only use 1 kilobyte of data. We're gonna need a lot more than that. Let's give people at least 10 gigabytes. My goodness, 1 kilobyte. Now we have two options here, limit disk space and set warning level 2. We'll make this a still unreasonable 500 kilobytes. That way I can show you what happens when somebody exceeds the warning level. Now here are two really important options. Log event when a user exceeds their quota limit and log event when a user exceeds their warning level. You almost always want to select both of these. What this does is it adds an event to the event log. Now you might ask, then what? Am I supposed to be opening up the event log every day to see whether somebody's passed their quota limit? I might as well just look at how much free space there is on the disk, right? Well, in an enterprise environment, the IT department will have tools for monitoring the event logs and all the thousands of computers that they have. So all you would do is you would set an alarm for when somebody exceeds their warning level or their quota limit. Then somebody in IT could be notified and that person could call Mary up and be like, Mary, you're using up too much disk space. Why don't you clean up some stuff? Now there's one option here that I didn't mention and it's really important to understand it. Deny disk space to users exceeding quota limit. You notice I didn't check it. I don't recommend ever selecting this checkbox. So if you do, what happens is when the user passes the limit here, they can't save another bit to the disk. They can't. The reason that's dangerous is it will cause all their apps to fail because apps are saving temporary files all the time. They won't be able to save their work. It's a real productivity killer when Windows won't let you save another file. And frankly, the error messages they'll be getting won't be all that useful. So if you deny disk space to users exceeding their quota limit, what'll happen is somebody will do that and everything will break and they'll flip out. A better way to do it is to monitor, log the events, and when they start to get close, call them, work it out, but don't stop them from saving stuff because that's going to break everything. So now that we've covered that, I'll deselect this and we can walk through an actual scenario. In this scenario, you're managing a computer for a small business and several different people use this computer. Here's the problem. Mary again, right? She's saving too many files and she's filling up the disk, and then somebody else gets on shift and they jump on the computer and there's no room for that person left to save files. So we got to try to rein Mary in, right? But we don't want to single her out. So what we'll do is we'll set up a disk quota on the computer that will just warn us by throwing an event when she surpasses the limit of the number of files that she can save. So we're back here at Windows 8, and just like I demonstrated before, I'm just going to view the properties for the disk and go to the quota tab, show the quota settings, and enable quota management. So with quota management enabled, we're going to limit the disk space to 10 gigabytes, but we'll set a warning to 500 kilobytes. This will just tell Mary that she shouldn't use more space than that. That's a low number, but it's going to be easier for us to simulate what happens at that point. And of course, we'll log events so that we can take a look at it later. Now you can see the disk quota dialog box here warns you that it requires a little bit of work to enable get disk quotas, and indeed it does slow stuff down a little bit. So you really only want to use disk quotas if you need them, but they make it hard enough that you're not going to turn it on accidentally, right? Obviously you need it. So I'll click OK to confirm that. And then click OK again. And now disk quotas are on. So let's become Mary. Logging on as Mary here. Mary who can't control how many files she makes. Oh, Mary. Let's go to the desktop. Let's see how many files Mary has at this point. All right, so she's got less than 1K of files here. Let's make a picture. Didn't actually mean to view the picture. I meant to edit the picture, so I'll right-click it and then click Edit. And, you know, I'm quite the accomplished artist, if I do say so myself. So I'll just draw a picture here. That's a self-portrait. And I'll save it. So now we have a file that is 800 kilobytes. So I'll copy that and paste it a bunch. All right, so let's see how many. Mary's up to 30 megs now. So that should be enough for the disk quota system to trigger an event. So I'll log back on as Tony, who has administrative credentials, and view the event viewer. So now we need to open up the event viewer, and I think the easiest way to open the event viewer is to open the WinX menu by holding down the Windows key and pressing X, and then selecting Computer Management. Computer Management is just a console that has all these other tools built into it. You'll see that from the WinX menu, there's also an item just for Event Viewer, but for consistency, I use the Computer Management console for everything. So within Event Viewer, I'll expand Windows logs, and then I'll select the system log. There are many different logs, dozens of them, but look at all these logs. So it's important to know which log Windows stores different types of events in. For disk quota, it appears in the system log, so remember that. Now in the center pane here, we can see a list of all the different quota entries. They're marked with the source of NTFS, so you can see that when I first enabled disk quotas, remember that message came up saying it needed to rebuild the user disk quota information? Well, this event marks that point when I confirmed that I wanted to use disk quotas. You can see that it was taken at 6:15 and 6 seconds. At 6:15 and 9 seconds, I got an event saying the quota system was successfully rebuilt. And exactly 10 seconds later, we discovered that a user hit their quota on the computer. And you can see a little bit farther up, indeed, every user on the computer has hit their quota threshold because I set the threshold so small. So looking through these entries, you can see down here the username, Win82Mary. So as an administrator, I would be looking out for this particular event with an event ID of 36 and a source of NTFS. Once I saw an event like this saying that a user hit their quota threshold, I would examine the event to extract the user information and the computer name. And that would tell me which user and which computer were defying my mandate to not use more than a certain amount of files on the disk. That's about all there is to know about disk quotas. So now we're going to learn about object access auditing. That's a complex phrase. Auditing is the process of monitoring what people do. It's a very technical term. It's a very security-oriented term. A lot of the times organizations need to audit things. Now, when we think about auditing, we usually think of taxes. And when the dreaded tax man comes to audit you, what he does is he looks through all your records and he just kind of double checks it. And if you've done something wrong, he calls you out on it. Well, that's what auditing is for computer systems too. Auditing isn't enabled for most stuff by default, but you can use auditing to monitor when people do just about anything on a computer. You can monitor when they log on, when they log off. That can kind of allow you to track their hours sometimes, a little trick. You can also monitor when they open particular files, when they change registry entries, when they print, when they attempt to open something but they don't have access, when they modify things. All these little actions have separate auditing entries that you can turn on to monitor them. So why don't you just audit everything just in case you ever need that information? The answer is you'd end up with this massive, massive audit log, and you'd never be able to find what you were actually looking for in it. So you really only want to audit a few things because otherwise there's so much noise you can't find what you need. Also, auditing slows the computer down. If you turn on auditing for every single file on the file system, every single time somebody accesses that file or any file, Windows is going to have to stop what it's doing and put an event in the event log. It slows things down just a bit, but the more auditing you have enabled, the more noticeable it becomes. So let's take a look at how object access auditing works. Back at Windows 8, let's open up File Explorer from the desktop here. And we'll take a look at file auditing. You can audit all sorts of different objects in Windows, but file auditing is definitely the most common. I'll audit the Windows folder. Now, from the Folder Properties dialog box, I'll select the Security tab, and then I'll click the Advanced button. You'll notice auditing isn't displayed on the standard Properties dialog box. It's not that commonly used. Now, the Advanced button shows you all your permissions in just a different way. It kind of summarizes them for you. And you can also use this tab to see a user's selective access. That's a cool and effective way to see what users have access to. But for now, we want to take a look at the Auditing tab. You can see, because it requires me to click this button, that I need administrative access. I have it, so I clicked it and it automatically elevated my privileges through UAC. Now the auditing list here shows all the existing auditing entries. That's this nothing here because there's no auditing enabled by default. However, you can add auditing for a user or group by clicking the Add button. From the Auditing Entry dialog box, the first thing you'll do is you'll select a user. Now, they call it a principal, but it's a user or group. So let's say we want to audit everyone. I'll type the everyone group name. Now I can select the type of auditing. There's always failure auditing and success auditing. Success auditing means somebody tried to access a resource and they had permission. They tried to open a file and they opened the file. That's a success. If they tried to open the file and they don't have access, that's a failure. Now the all option here enables both failure and success auditing. So what success auditing tells you is what people did, and what failure auditing tells you is what people tried to do but couldn't do. So imagine that you work for a healthcare company and you are required to audit everybody who goes in and changes somebody's health records. You need to know exactly when and exactly who edited anybody's file. You would go in and enable success auditing. For regulatory purposes, you wouldn't care if somebody tried and failed. After all, they didn't actually do anything. Maybe it was an accident, it probably was. But you would need to track everybody who successfully audited a record. That way, if that person called in and complained that somebody put something incorrect in their record, you could go through the audit logs and determine exactly who it was, what computer they were using, what time of day that they did it. You could see, well, you wouldn't be able to see the exact changes that they made. You'd be able to see everybody who edited that file. Failure auditing is good for kind of detecting hackers. You could perform failure audits for lots of different important files on your company. If you have this shared folder called personnel records, I bet you'd see more than a few people going in there trying to open it up to see what other people's salaries are or to find personal information about them. If you want to find out who's trying to do stuff, enable some failure auditing. Usually, whether it's an automated attack or a smart hacker who's trying to get to something, they don't succeed on the first attempt. Usually they try to access something 20 different ways. And in that case, failure auditing would give you some pretty useful information, might even be able to allow you to detect the attack in progress before the person succeeds. Now we have the applies to list here, and this is pretty self-explanatory. You can select just the folder itself or the folder and all the subfolders and files within it and any combination of those things. And using these settings, you can control which types of actions are audited. Because we're auditing success here, if I select the modify checkbox, then it will add an entry to the security event log anytime somebody successfully modifies a file. If I clear read here, then it won't add an entry when people read an existing file. But because write is still selected here, it would add an entry when somebody created a new file. So those are the different combinations that you can specify. So that's the fundamentals of file auditing. Just so you can see how it applies to different types of resources, I'm going to go back to the start screen here and run the registry editor. I'm just typing regedit, which is the name of the registry editor. Requires administrative credentials, and for some reason it's not considered part of Windows, or it wouldn't prompt me for a UAC prompt. Now, the registry editor is this pretty outdated system of settings that apply to the entire system and to individual users. The registry, you rarely have to interact with it anymore, but back in the day, you had to interact with it all the time. And all the objects in here support auditing because they are critical system resources, and therefore it's important to know who might be, say, adding something that would start automatically, like malware. So I'll right-click any of the registry locations here and click Permissions. And just like files, from the Security tab here, I'm going to click the Advanced button. And you can see this is identical to files, it uses the exact same user interface. The auditing is always just fail or success. And of course, this works similarly. Just like files, I can select whether it's just that folder or the objects that are within it as well. And the permissions, of course. Registry entries don't have all those different permissions. It's pretty much you can either read it or you can do whatever you want to it. So they don't break it down any further than that. So the permissions are a little bit different. The options you have here for applying it are a little bit different. But overall, it works exactly the same, whether it's a file or registry or some other type of resource, including, say, objects that exist in the Active Directory in a domain environment. So with those fundamentals down, let's go through a scenario. So in this scenario, we're going to use auditing to track a hacker. We're going to put an important file out there, some user payroll, and then set up auditing so that if anybody tries to open it, we'll know who they are and when they did it. So let's jump onto our Windows 8 PC. Let's see, we're already on the desktop here in Explorer. You can see there's a payroll folder here. Let's just check the file permissions on it. All right, now Mary should not have access to this, and you can see the file permissions reflect that. She's got deny access. Because she has deny access, even if she's a member of the power users group, which can open it, well, the deny is always going to overwrite that. So Mary should not have access to this. Now let's set up some auditing. Now, before we do anything, we need to edit the local security policy. So I'm going to go back to the Start menu and run a tool called secpol, S-E-C-P-O-L. secpol.msc, the Microsoft Security Console. And this is our local security policy. Now, under local policies here, and then audit policy, we need to enable object access auditing. There's a reason that it's turned off by default, and that is that object access auditing slows everything down, because Windows suddenly has to watch what everybody's doing, and if they do something that's audited, it's got to add an event to the event log. Really slows stuff down. So I'm going to open this up and turn on both success and failure auditing. Now you can see there are other types of auditing. The exam objective just talks about object auditing, so that's all we're interested in right now. So with object auditing turned on, I'll close the local security policy and then edit the auditing settings for the payroll folder. I'll click the Advanced button on the Security tab of the Properties dialog box and go over to the Auditing tab here, elevate my privileges, and click the Add button. Now for the principal, I'm not trying to single Mary out, even though I kind of got my eye on her. I'm going to select auditing for everyone, and I want to know about both successful and failed attempts to access the file, and I'll select all the basic permissions. You can see here, because I'm selecting folders, subfolders, and files, the critical files within the folder will be automatically audited using inheritance. So I'll click OK multiple times to close it down, and let's just check out the audit settings on this salaries file here, and we'll make sure that the inheritance worked. There we go. The file itself also is audited. Actually, you know what I'm going to do to make this a little bit more of a compelling sting? I'm going to grant Mary access to this. I'm just going to tell her that she shouldn't do it. So she's denied access now. Let's grant her access. And we'll just confirm that Mary also has access to the file within it. Okay, so we're going to allow Mary to open the file with NTFS permissions. We're going to audit to see if she actually does, and then I'm just going to tell her, don't look at people's salaries. That would be wrong. Oh, you know Mary, though. Let's log in as Mary and see what she does. All right, I'm Mary. I am a curious little monkey, and I would love to see people's salaries. So I'll open up the desktop and explore here. What? I see a new folder called Payroll. I would love to see people's monies. So I open up Payroll. I'll open up the salaries folder here. Whoa, Tony Northrup makes zillions. That's really impressive. I'm going to put that on Facebook or something. All right, so Mary's done something naughty, and auditing will reveal it. So we'll log on as our administrator account once again. Now, to see a record of what has been audited, you need to use the Event Viewer. So I'll open up the WinX menu here, and this time I'll just open up Event Viewer directly. All audit entries go into the security event log, which is nested within Windows logs. Right at the top here, we see a couple of audit failures. Now, that's funny. This is completely unrelated to what we were trying to do, but it's a good demonstration of what happens with auditing. There's always just a ton of noise. It can be really tough to weed through all the different audit entries. In fact, for organizations that really need auditing, they end up buying a third-party auditing tool, or they end up buying management tools that kind of filter through these things. So this audit, you can see that the event itself relates to me opening up Event Viewer. Object name, eventviewer.msc. So it seems a little odd that it was an audit failure because I successfully opened Event Viewer, right? Well, it turns out within the Event Viewer tool, it tried to access a particular resource that I didn't have access to. I'm an administrator, so nobody has access to it. But regardless, sometimes apps just try to access everything, and that's what happened here. It's a meaningless audit failure, but I show it to you just as an example of the types of stuff that you have to weed through. Now, there's also lots and lots of success audits here. So now we need to weed through them to find the one where Mary was logged in. So we can see at the top of all these events, it's telling you the account name. And we know we're looking for Mary's entry, but first we have to weed through all the stuff that I did, even though I was behaving myself. These are events made by the local service. Oh no, the Windows filtering platform blocked a packet. There are so many packets coming into a computer at any point that the firewall blocks. They're not all malicious. But once you enable auditing, Windows is going to be adding these entries for everything that goes on. Again, I'll just keep scrolling down to see if we can find Mary's particular entries. So here we've finally found the entry that we're looking for. You can see that for this particular entry, an attempt was made to access an object. It specifies the account name, the account domain, which is the name of the computer in this case, but if you had an Active Directory domain, it would be that. And it says the object name, the payroll folder. The object type, of course, is a file. And you can see here that the attempt to access it was a read attempt because she didn't attempt to modify the file. She simply opened it. So this particular entry occurred when she actually opened up the folder, but we can see other entries that would relate to the specific file. So as you can see, as you read through here, you'd be able to determine the exact time that Mary accessed the file, the account she was using, the computer she was on, and precisely what she did, so she could be real busted. But you can also see that there's a lot of junk already in the security event log. And in fact, there's so much junk that it would fill up your entire hard drive with stuff you didn't care about. So it recycles it after a certain amount of time. It might be getting rid of critical events that you really need to log, especially if you are bound by regulations, as many government agencies and healthcare agencies are. So if you use object auditing for regulatory purposes or security purposes in general, be sure to configure event log to back up that log on a regular basis so you can go back in time and look at these older events. You'll also have to manage the storage because it's going to fill up pretty quickly. And do your best to filter through the different auditing events and turn off auditing whenever possible. If you aren't really interested in something, turn off auditing for it because it's just going to make it that much harder to find the events that you're looking for in the future. This is Tony Northrup for TrainSignal, and I hope you found the lesson both educational and enjoyable, and I'll see you next time.